everyone, it's Mrs. Martello. We're going to look at section 5.2, and in this chapter we are still solving systems of linear equations, except here in this section we're going to solve by substitution. So this is just another way of solving systems. We could use graphing or we could use this method, and we'll learn one more method in the next section as well. So here are the steps. I would suggest you pause this video and write these steps down. These steps are really helpful in learning how to solve by substitution. So your first step is you need at least one of the equations to be equal to one of the variables. So if one of the equations is already equal to a variable, like it's already x equals something or y equals something, then your first step is done. But if neither equation is equal to a variable, then you have to solve one of the equations for one of the variables. Step number 2 is you're going to substitute the expression that you get from step number 1, whatever that variable is equal to, you're going to substitute it into the other equation for that variable, and then you're going to solve that equation. So what you're going to notice is all the variables are now the same and you can solve. Okay, but this is not the answer. Remember that the solution is the point of intersection. It has to be a point, an ordered pair, which is x and y. So this only gives us one of those coordinates. Our next step is to find the other coordinate. So we're going to substitute the value that we found from step 2 into one of the equations and solve to find the other variable. Let's look at example 1. So it says we're going to solve this system of linear equations by substitution. Our first equation, y equals negative 2x minus 9, and our second equation is 6x minus 5y equals negative 19. So what I want to notice is that this first equation is already equal to a variable. It already says y equals. So what I'm going to do is I'm going to take this expression that y equals, I'm going to take this negative 2x minus 9, and I'm going to substitute it into the other equation for this y. So instead of it being negative 5 times y, it's going to be negative 5 times this quantity here because y equals negative 2x minus 9. So that's going to go in for this variable here. So let's show our work. We have 6x minus 5y equals negative 19, and we're plugging that expression in for y. We're going to keep the 6x, we're going to keep the minus 5. When we plug that expression, that negative 2x minus 9, we're going to use parentheses because it's negative 5 times this whole expression, and we're going to distribute that negative 5. And then this equals negative 19 stays. Look at this equation now. It only has x's in it, so now I can solve for x. I'm going to distribute the negative 5 to get positive 10x and positive 45. We'll combine our like terms to get 16x. Subtract 45 from both sides, divide by 16 on both sides, and we get x equals negative 4. Now this is not the solution. Remember, the solution is an ordered pair. I need x and y. So now I'm going to take this x and I'm going to plug it into one of the equations. It doesn't matter which one you plug it into, and I'm going to find y. Since this first equation is already equal to y, I think this equation would be an easy one to help me find out what y equals. So let's plug it in for x in here. So we have y equals negative 2x minus 9. We're going to plug negative 4 in for x. Negative 2 times negative 4 is 8, minus 9 is negative 1. So now I found my x up here, my y down here. I'm going to write it as an ordered pair, x comma y, negative 4, negative 1, and I just found the solution. Remember that you do want to take the time to check your answer for this because it is so much work. It is worth your while. To check your answer, you do what we did in section 5.1. You take this point and you plug it into both of the equations and make sure that it makes both of them true. So the check is over here on the side. Let's plug it into our first equation. Negative 1 equals negative 2 times negative 4 minus 9. This one works. And then we'll plug it into our second equation. 6 times negative 4 minus 5 times negative 1 equals negative 19. And this one works as well. So we're good to go. Let's take a look at monitoring progress 1. So in monitoring progress 1, we have our system y equals 3x plus 14 and y equals negative 4x. We want to solve by substitution, and then we'll check our solution. So our first step that we set up here was we need to have one of the equations equal to one of the variables. And actually in this problem, both of the equations are equal to a variable. So it doesn't matter which one we substitute into the other. I could substitute this expression into this y, or I could substitute this expression into this y. I think I'm going to take the shorter expression and substitute it in. Let me go over to my paper here so you can see what I'm going to do. So I wrote down the system, and I'm taking this, what y equals negative 4x, and I'm going to plug it into this equation for this y. So instead of it being y equals 3x plus 14, let's plug in negative 4x. So it's negative 4x equals 3x plus 14. And now I can solve this equation for x. Let's subtract 3x from both sides. I get negative 7x equals 14. I'm going to divide both sides by negative 7, and I get x equals negative 2. Now remember, this is not the solution. I still need to keep going. I need to find y. So I'm going to take my x and plug it into one of these equations to find y. Let's plug it in the second one because this is a shorter equation. Y equals negative 4x. Let's take this x and let's plug it in. Y equals negative 4 times negative 2. So I get y equals 8. Now I'm ready to write this as an ordered pair. My ordered pair, the x is negative 2 and the y is 8. And that is my solution to the system. So if I wanted to check this in a different way, I could graph it. I could graph these two lines and find the point of intersection. I could graph it by hand, or I could graph it in my calculator. Let's just double check and let's show it in our calculator like how I showed you the last time. Let me clear out these equations, and I'm going to plug these two equations in. 3x plus 14 and negative 4x. Let's graph it. Okay, and it looks like the point of intersection is right about here. So instead of me estimating, I'm going to use that feature in the calculator, which is up here in calc. So I'm going to do second calc and then intersect. First curve, enter. Second curve, enter. Guess, enter. And look at this, our intersection point is negative 2, 8, and that's exactly what we found here. So you can solve by graphing, but you can also solve by substitution. Okay, we can also check our answer by taking this point and plugging it into both of our equations. We could check it that way too. So let's do that for fun. Remember, this is your x and this is your y, so be careful plugging it in. This is going to be 8 equals 3 times negative 2 plus 14. 8 equals negative 6 plus 14. Yep, that one would be true. Let's plug it in the second equation. 8 equals negative 4 times negative 2. Yeah, 8 equals 8. This one also works, so I know that one is true. Let's do another one like this. We're going to do number 2. So number 2, we have 3x plus 2y equals 0, and y equals 1/2 x minus 1. We're going to solve by substitution. So to solve by substitution, look at your second equation. Do you notice how this equation is equal to our variable y? So I'm going to take this expression of what y equals from the second equation, and I'm going to plug it into this first equation for this y. So let's rewrite this first equation, and instead of it being 2 times y, it's going to be 2 times this quantity here. So our equation would be 3x plus 2 times our y is 1/2 x minus 1, and then equals 0. So I substituted what y equals into this first equation for y. And now let's solve this equation. We're going to distribute the 2. We get 3x plus 2 times 1/2 x would just be x. 2 times negative 1 is negative 2 equals 0. We're going to combine our like terms. 3x and x makes 4x minus 2 equals 0. Let's add 2 to both sides. 4x equals 2. And we'll divide both sides by 4. And we can write our answer as a fraction, or we can write it as a decimal. It doesn't matter. I'm going to write it as a fraction, 1/2. Okay, we're almost done. Now we're going to take our variable that we just found, our x, and we need to find y. Don't forget our solution is an ordered pair, x comma y. Let's take our x, I'm gonna plug it into this second equation so I can find y. Y equals 1/2 x minus 1. Let's plug in 1/2. Y equals 1/2 times 1/2 minus 1. This would be y equals 1/2 times 1/2 is 1/4. And then if I want to subtract this, I need to have a common denominator. So instead of it being minus 1, let's write it as minus 4/4. So 1/4 minus 4/4, that's going to give me negative 3/4. All right, I found my two variables. I'm going to write my answer as an ordered pair. My ordered pair would be 1/2 for my x and negative 3/4 for my y. And that would be my solution. Let's keep going. We're going to take a look at example 3 now. In example 3, what we notice is we're still going to solve by substitution, but neither of the equations is going to be equal to one of the variables. So we're going to have to make one of the equations equal to one of the variables. So it's your decision to decide what variable you want to solve for. You could solve for the first x, the first y, the second x, the second y. It doesn't matter. But it is easiest to pick a variable that does not have a coefficient. So when it's just the variable and there's no number in front of it, that's going to be the easiest one to solve for. So I'm going to write myself some notes here. This is 5.2 continued. So if neither equation is equal to a variable, you're going to pick a variable without a coefficient to solve for. Okay, so that's what you want to do. That's going to be the easiest way. So it doesn't matter which variable you pick. I would go with one of these y's. It doesn't matter which one. And in this problem, they decided to pick equation number 1. So we're going to do this example together, example 2. I'm going to write down the first equation, negative x plus y equals 3. Let's solve this equation for y. So we're going to add x to both sides. I get y equals x plus 3. Now this equation is equal to a variable. Now I can do substitution. So I'm going to write down my second equation. I didn't do anything with it. It's still the same. It's 3x plus y equals negative 1. I'm going to take my expression that I just solved for in the first equation, that x plus 3, and I'm going to substitute it in for y into this second equation. So now it's going to be 3x plus x plus 3 equals negative 1. Now we can solve for x. Let's combine our like terms, 3x and x, that makes 4x plus 3 equals negative 1. We're going to subtract 3 from both sides. 4x equals negative 4. Divide by 4, we get x equals negative 1. Now let's solve for y. So to find y, I'm going to take my x and I'm going to plug it into one of the equations. Now remember, I have 3 equations. I have the original 2, and I have this new equation that I solved for that's already equal to y. I think I'm going to pick this equation because I'm trying to find what y equals, so this would be the easiest one to plug it in for. So let's plug it in. Y equals x plus 3. We're going to plug in negative 1. Y equals negative 1 plus 3, and I get y equals 2. So let's write our solution as an ordered pair. My x is negative 1 and my y is 2. Okay, we can easily check our work here to make sure that I know I got this correct. Let's just do it mentally. We're going to take this point and plug it into both of these. Let's make sure it's true. The opposite of x, so that would be positive 1 plus our y, which is 2, equals 3. 1 plus 2 equals 3. That one works. Let's plug it in this second equation. 3 times negative 1 is negative 3, plus 2 is negative 1. So I know that that one works as well. Let's do one more like this just to make sure that we get the hang of it. We're going to do monitoring progress number 7. Okay, for this question, again, we want to notice that none of the equations are equal to a variable. None of them say x equals or y equals. So I'm going to pick one of the variables to solve for. I have this x, this y, this x, and this y. Remember what we said, we want to pick a variable that does not have a coefficient, and the only one that doesn't is this first x. So that's definitely going to be the easiest variable to solve for. Let's solve for the first x in this first equation. So I'm going to write that equation down. X minus 2y equals 7. Let's solve for x. We're going to add 2y to both sides. And I get x equals 2y plus 7. Okay, we're ready to do substitution. I'm going to write down my second equation here, right underneath it. 3x minus 2y equals 3. I'm going to take this expression that I just found for what x equals, and I'm going to plug it into the other equation for this x. Let's substitute. We're going to have 3 times, use parentheses, we're going to plug in this expression, 2y plus 7, then keep going with your equation, minus 2y equals 3. Now this equation only has y's. Let's solve for y. We're going to distribute 3. We get 6y plus 21 minus 2y equals 3. Let's combine our like terms. 6 minus 2 would be 4y plus 21 equals 3. We're going to subtract 21 from both sides. 4y equals negative 18. And we're going to divide both sides by 4. You can write your answer as a fraction or as a decimal, and that's totally up to you, whatever you're more comfortable with. If you want to write it as a decimal, that's totally fine. I think I'm going to leave it as a fraction though and just reduce it. This would be negative 9 over 2. But as a decimal, this would be negative 4.5. So it doesn't matter, whichever one you prefer. Okay, remember, we're not done. We still need to solve for the other variable. We just found y. Now let's find x. So I could plug it into any of the equations. I could plug it in the first equation, the second equation, or I could plug it into this new equation that I found here, x equals 2y plus 7. Since I want to find what x equals, it makes sense to plug it in the equation that says x equals. Okay, let's plug it in. X equals 2 times negative 9 over 2 plus 7. These 2's would just cancel out, so this would be x equals negative 9 plus 7, and I get x equals negative 2. Let's write this as an ordered pair. The x is negative 2, and the y is negative 9 over 2, and that would be the solution. Let's look at a word problem. We're going to take a look here at example 3. Okay, in example 3, we are going to write our own system, and then we are going to solve the system. So just be careful when you're writing the system. Think about how you are going to write your equation. Let's write down a couple important things to keep in mind here. So this is for word problems. Our first step is we need to write 2 equations. Remember that a system has 2 equations. So to do this, you need to make sure that you separate the 2 topics that they are talking about. One equation is going to be about one of the topics, and the other equation is about the other one. Then once you write your 2 equations, then you can go ahead and solve it. Okay, you want to think about what form are your equations going to be in and how the equation is going to be set up. So let's take a look here. So step number 2 would be then to solve. Okay, in example 3, a drama club earns $1,040 from a production. A total of 64 adult tickets and 132 tickets are sold. An adult ticket costs twice as much as a student ticket. Write a system of linear equations that represents this situation and what is the price of each ticket. So I think the first thing I'm going to do is I'm going to write my equation about the total tickets. This was the total money earned from the tickets. This was the total of adult tickets. This was the total of student tickets. Let's put that together as an equation. So if it's 64 adult tickets, let's say that the A, we're gonna make A our variable, stands for the cost of an adult ticket. And let's say that S is gonna be the cost of a student ticket. Okay, now that we have defined our variables, let's write our equation. 64 adult tickets at A dollars, so we're gonna have 64A, plus 132 student tickets at S dollars per ticket is gonna give me a total amount of $1,040. And there's our first equation. Let's write our second equation. It says an adult ticket costs twice as much as a student ticket. So the cost of an adult ticket A is equal to 2 times the amount of a student ticket. So 2 times S. That's gonna be our second equation. Now we're ready to solve. We're gonna use substitution. So our second equation is already equal to A. Let's take what this A equals. We're gonna plug it into this equation for A. So let's plug it in. We have 64 times 2S plus 132S equals 1040. Let's solve for S. This is gonna be 128S plus 132S equals 1040. Let's add these two together. These are like terms. 128 plus 132, that's going to be 260S equals 1040. And if you want to just check my math here, you can use your calculator. 128 plus 132 is 260. And now let's divide by 260 on both sides. 1040 divided by 260 is 4. So that means that a student ticket costs $4. $4 for a student ticket. Okay, let's find the cost of an adult ticket. I'm going to use this equation that's already equal to A. A equals 2S. And let's plug this in for our S. We're going to plug in 4. A equals 2 times our 4. And that's going to give me 8. A equals 8. So that means that it costs $8 for an adult ticket. Okay, if we want, we can write it as an ordered pair if we'd like, but we don't really have to because we described what they stand for. It's $8 per adult ticket and $4 per student ticket. And that's all we have to do for this. What is the price of each ticket? And we found that. If we want to, we can check our answer. So I'm just going to show you down here that they checked it. They plugged in the 8 and the 4 into the first equation and it was true. Same thing in the second equation and it was true.